Welcome to this video tutorial on even more problems pertaining to the trig functions with the unit circle. In this scenario, we are looking at a problem posed where we know a particular value of the cotangent and we know the quadrant in which this angle is located. So our notation up here is telling us that theta is in quadrant 4. So when we're approaching this problem, we know that the angle we're discussing falls in the fourth quadrant over in this realm of our axes. Now, one of the things that we look at here is we draw a right triangle and we're going to call one of its angles theta. And what we're going to do then is talk about the cotangent in terms of either adjacent over opposite, or when we're talking about it in terms of the unit circle, it's x over y. So in this case, we have an 8 for the x, because that's the numerator, and a 1 for the y, or vertical component to that angle, since that's the denominator. We will use the Pythagorean theorem to solve for the hypotenuse, and hopefully we can see that's just going to be radical 65 in this particular problem. So now when we go to identify the other items, we can just look at this triangle in all honesty. The sine would be the opposite over the hypotenuse, which is 1 over square root of 65, and then we're going to rationalize it, get that square root out of the denominator when we simplify our answers. Cosine is adjacent over the hypotenuse, so it'll be 8 over square root of 65. Again, we will rationalize it, and when we rationalize it, it'll turn out to be 8 radical 65 all over 65. Look to reduce things. 8 and 65 don't have any common factors. Now the tangent is just the reciprocal of the cotangent, so we'll know that's negative 1/8. The secant. Now the secant is when we take and use the reciprocal of cosine, so I can just write this as radical 65 over 8, and the cosecant is the reciprocal of sine. The last question that we have to ponder is positive or negative. In quadrant 4, the x-coordinate is positive and the y-coordinate is negative. So what we should see are the functions tangent and cotangent both negative because of the fact that one is positive, one is negative. The sine is going to have to be negative because of the fact that the y-coordinate is negative, as will the cosecant. But the cosine and the secant are both going to be positive. So when we write out our final answers, we need to ensure they're simplified. Please be careful about whether they are positive and negative. And there we go. Now there's one other type of problem that we could look at, and that's what we're going to see right here. In this problem, we're given a value that actually appears on the unit circle. So here we're saying that the cosine of theta over 3 is equal to a negative 1/2, and we're focused on theta over 3 coming from the second quadrant. Theta over 3 being negative 1/2 means that this angle is the tall one, and that means that theta over 3 is going to be equal to 2 pi over 3. So theta over 3 equals 2 pi over 3. Now we're trying to go through and figure out what theta is because that's what we're evaluating, or what we're hoping to evaluate. So we would multiply through that equation by 3, and we'll get that theta is equal to 2 pi. So now when we look at these evaluations, we are considering what's the case over here when theta is equal to 2 pi. Well, the sine of theta is the y-coordinate, which is 0 at that location. The cosine of theta is the x-coordinate, which is 1 at that location. Tangent, be careful, tangent is y over x. The y is 0, so that's going to be 0. But now when we take the reciprocal of tangent, 1 divided by 0 does not exist. So here the cotangent does not exist. Don't get caught off guard with that. For the secant, secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Again, we cannot take the reciprocal of 0, so we get it does not exist. Basically, in these type of problems, you've got one of two things that happen. Either it's not a known area of the unit circle, and we employ this Pythagorean theorem right triangle technique, or it is a point that we know from the unit circle, and maybe you need to be careful to watch out for changing an input from some multiple of theta to some other multiple of theta before you evaluate using your unit circle.